can make it a little bit bigger probably. Okay. Only thing is it keeps wiping me off of this part. Okay. All right, so let's take a look at this. You did a frequency. You did a frequency to see how many households have 0 dogs. Interpret your table first. Out of all of these households, 2,175 households, 1,491 have no dogs. You did your tally. This is the frequency from your tally. People with having 1 dog, there were 425 households that had 1 dog. So interpret your table before you even start so that you understand where the numbers come from. So my probability says if I looked at the next household, what is the probability that they have no dogs based on this current trend? So if I find the probability of these things happening, part over whole, I add up my frequency, I do part over whole, part over whole. Now I can say, if I'm at random choosing a household from the same population, the probability that that household does not have a dog is very close to 69%. Okay, because a lot of people did not have dogs in this population, or this sample rather.
It's like backwards, like it gave us the probability, but not the households.
They gave you the number of households, they gave you the frequency. You had to figure out the probabilities.
Where is that though? It's not. They didn't give us the households, they gave us the probability instead.
Oh, do I have this backwards?
Yeah, that's why I didn't get when you had it up there.
Oh.
I didn't know what to do with that stuff.
Oh, so they gave you this. So what did they ask you to? Oh, they just want you to find the mean, the median, and the mode?
Yeah, that's fine.
Oh, okay. Oh, they want to say, I'm sorry. I don't know where I got those numbers from. This must be an old one. This was probably from the old book. I'm sorry. Okay, so you were given this, just these 2, right? So, ups, nope, just these 2. Okay, not this. And remember, if we want to do this by hand, we multiply our x times our probability, and we get this column. If we add all this up, this gives you the mean. If you don't want to do that column, you don't have to do that column, because you can put this in your L1 and you can put this in your L2. But make sure you do this. 1 var stat, L1, comma L2. If you don't put the L2 in, all you're taking in averages is 0, 1, 2, 3, 4, 5.
On the quiz, are you going to give us the probability, or are you going to give us like...
I'm probably going to give you the frequency, and you're going to find the probability. Yeah. Okay, so can everybody work their way backwards and take the standard deviation and find the variance? Do you remember how to do that? So when you've got, when you have a standard deviation, the calculator gives you the standard deviation. When we work out that whole table, we get the variance, we square root it, we get the standard deviation. Your calculator, you have to go backwards. So when you get your standard deviation, you go to VARs, you go down to number 5, and you plug in my population standard deviation, and you square it. When you square that, that's your variance. Okay? That's your variance. Standard deviation mean, I guess that was all you had to do, right? So what does this mean when I see 0.5? Can someone have 0.5 dogs? But when we're taking an average, remember our average contains 1 decimal place more than your x values. Are these x values discrete or continuous? Discrete. They're countable. I can't count a half a dog. My average can come out a half a dog, but my counting of them is a discrete variable. You have 1 dog, 2 dogs, no dogs, 5 dogs, 10 dogs, but you can't have a 0.5 dog. But when we take an average, because your average is 1 more decimal place, you can have a 0.5 dog. So somewhere between the 0 and the 1, people have dogs. Good with this? Okay. Then I gave you hopefully this one looks the same. Number 38. So number 38 said a charity organization is selling $5 raffle tickets as part of a fundraising program. The first prize is a trip to Mexico valued at $34.50. The second prize is a spa package at $7.50. The remaining 20 prizes are $25 gas cards. The number of tickets sold is 6,000. You have to know that, right? So if you were to buy all 6,000 tickets at $5, how much would you have spent? A lot. So 6,000 times 5, you would have spent $30,000 just to win all those prizes. Does those prizes add up to 30,000? They're far less. So if you did that, would you come out winning or losing? Losing. You should have taken your $30,000, bought yourself a vacation or two, and then did all these other things instead of put into this raffle. God bless. But it is a charity organization, right? So charity organizations have to make money. All right, so again, we look for where are your gains and losses. Since you spent $5 already, this is not what you made, not what you won. You won this minus the $5 you put in. So you get $34.45. Make a chart like this. Whether you make it this way or this way, that's fine. Doesn't matter. Then you say, same thing here. $7.50, you make $7.45. That's your net gain. $20, it was a $25 gift card. I only make $20 back. If I don't win anything, I have lost my $5. I have nothing to show for my $5. Out of 6,000, there's only one trip to Mexico. There's only one spa package. There are 20 gas tickets. So that's why this one has 20. So when we do some, just leave them all. Unless you want to get rid of some zeros, I would just leave them. Add the 20 plus the 1, and then subtract this from 6,000. Subtract it from 6,000, that's where the rest of the tickets come from. So if you want to do this with your calculator, this is L1, this is L2. Because we said the expected gain or loss, the expected value, is the mean. So you can do it in your calculator takes negatives, you can do it in your calculator, or you can do it like your calculator would. Since all of these probabilities add up to 1, your calculator says multiply these, add them all up and divide them by n, and n is 1. So we're doing basically the same thing that your calculator does. We're multiplying these, and then we're just adding up the sum. So the expected value is the mean. You can use your calculator for that, L1, L2.
How did you get a 5,970 again?
Because we said there's one ticket for this guy, there's one ticket for a spa package, there are 20 gas tickets. So altogether, if I add those up, there are 22. If I subtract them from 6,000, because I'm selling 6,000 tickets, I have 5,978 tickets that are not going to win.
Yeah.
A lot of tickets.
Awesome.
So another thing when you look at probabilities, what are your chances of winning when it's 6,000 tickets and there's really only 23 prizes? Not good. 22 prizes, whatever this is, 23 prizes. It's not very good. There's only 22 prizes to win, and they're selling 6,000 tickets. Unless you feel like you're an extremely lucky person, or you really want to give to this charity, which is probably a worthwhile charity, you do it. Yeah. Yes.
Why is it $20 not $5?
Because when you give me your $5, you just paid me $5 to win back 25. So what is your net gain? We have to take out your $5 that you paid. Yeah. And so that's why this guy is losing $5. You gave me $5, but you didn't get anything back. You didn't win anything. So overall, you can take that off your taxes, income tax.
So you have to add $5 to everything on yours?
No, you have to take away $5 from everything. Because you paid $5 for your ticket.
Then you take away 5 again at the end?
No, you don't. No, this is if you won, you lost. So say you give me your $5 for your raffle ticket and you didn't win anything. Overall, what did you do? You lost $5. And they will be 5,978 people just like you that lost $5.
And you multiply -5 that fraction?
Yeah, yeah. Which is why you're a loser, because the prizes don't add up to not why you have the losing tickets, because your prices don't add up to what this came to, right? The overall $30,000 is a lot for this organization to make and only spend this much money. This plus this plus this. That's all they're spending. So what is that? Like a little over $4,000? They're spending a little over $4,000 to make $30,000, which is the goal of a fundraiser, right? Okay, so we get that.